Okay, in this video, we're going to be doing Calc BC Problem Set number 14. The questions and the playlist are in the description below. Let's take a look. Given the differential equation, dy dx equals a quantity y minus 3 times a quantity y plus 1 and its slope field above, which I've drawn below. Sketch solution curves through the three indicated points. All right, so point A is starting at y equals 3. And you can kind of see from the differential equation, if y equals 3, the slope is always 0. You're just going to get a horizontal line. B is kind of the same thing, right? If you start at y equals -1, plug that into dy dx, you always get 0. So again, you're going to get a horizontal line. Those are just going to be constant solutions. Like there's no way to get out of there. On the other hand, if you start at C, what you want to do is picture this as flowing water and just kind of like follow the trend, right? So if we go to the left, we'll go up, and then you get kind of caught in the current there and you just follow that solution along there. If you go to the right, on the other hand, you kind of immediately or a little bit faster get to this and you just follow the trend. That's what our answer would look like. It's important to realize the range for this solution is -1 to 3, and you will never get to -1. You will never get to 3, because if you did, then the slope would become 0 and you would never change again. All right, let's take a look at part B. Solve for the particular solution that is going through 0, 0. All right, so you can see x is the independent variable, y is the dependent variable. We have to separate and then integrate. So we got to get everything with a y on one side, everything with an x on the other side. So I'm going to say dy over y minus 3, y plus 1 is equal to 1 dx. So I like to write the 1 there. You don't have to. For some reason in my mind, I find it confusing if I just have to do the integral of dx. I don't know. The integral of 1 dx, not confusing. The integral of dx, I'm like, what? Throw in some integral signs and you quickly realize that this is going to be partial fractions. So let's set up our partial fractions. We got a over y minus 3. We have b over y plus 1. And then when we combine those, we should get 1 over y minus 3 times y plus 1. And so we got to do the partial fraction. So we're going to let y equal -3. If we, -3? Why should it be +3? We're going to let y equal, hold on, I can fix this just by deleting that because I don't think I made the mistake. I don't know why I said -3. Let y equal 3. Cover up the y minus 3, plug in +3, we get 1 over 4. So, small mistake, did not carry it through. That's good. If we let y equal -1, cover up the y plus 1, plug in, we get b equals -1/4. It's always nice when you make a mistake that doesn't carry through. All right, so we can rewrite this thing as +1/4 over y minus 3, -1/4 or -1/4 over y plus 1. And then dy, that's going to be equal to the integral of dx. Left-hand side, I'm going to factor the 1/4 out, and then it's just straightforward natural logs. So 1/4 quantity, natural log absolute value of y minus 3, minus natural log absolute value of y plus 1. On the right-hand side, we just get x plus c. So remember, c goes on the side with the independent variable, which in this case is x. On the left-hand side, so I'm going to do two things here. I'm going to multiply both sides by 4. To just get rid of that 1/4. It's kind of annoying on that side. So multiply both sides by 4. And then also, I'm going to use properties of logs where subtraction between them becomes division within. So I'm going to have natural log absolute value y minus 3 over y plus 1. So that subtraction between becomes division within. 4x, and then technically you get 4 times that previous c. I'm going to change the color. It's a new c value, but we don't actually really care about that. In fact, now, because y is inside a natural log, I'm going to exponentiate before I try to solve for c, which means I'm going to create another new c. So y minus 3 over y plus 1 is equal to ce to the 4x. So it's really e to the 4x plus c plus that original c, but it's also plus or minus e to the 4x plus that original c. It's just easier long-term and short-term if you create a new value of c there and just say ce to the 4x. I have a bunch of videos on that. I do that all the time. I never mess around with that absolute value. Let's solve for c. So 0, 0. We're plugging in 0, 0, so you're going to end up with -3 over 1, so -3. And you get ce to the 0, e to the 0 is 1, so c is -3. If we take all that and just sub in, we have y minus 3 over y plus 1 is -3 e to the 4x. I'm going to do a little trick here, where I really want to get y plus 1 over y plus 1, so I'm going to add and subtract 1, and that'll give me y plus 1 minus 3, so y plus 1 minus 4. over y plus 1. So that's the plus 1 minus 1 trick. I use that frequently to avoid doing division. And now I'm going to break it up. Y plus 1 over y plus 1 is 1. And then minus 4 over y plus 1 is equal to this side here. And then what I'm doing is I'm doing like every step at once here. So I'm going to subtract 1, multiply by a negative, take a reciprocal, multiply by 4, subtract 1. That's all algebra 1 stuff, but I did a lot at once. So my final answer is -1 plus 4 over 1 plus 3e to the 4x. If you check that on a TI-Nspire, it gives you a slightly different looking answer. It just gets a common denominator. All right, let's take a look at part C. Right, the second degree Taylor polynomial for the particular solution through 1, 1. Okay, so we're going through 1, 1, so we know that f of 1 is definitely 1. We need to know what f prime of 1 is, but f prime of 1 is just going to be the derivative evaluated at 1, 1, right? So let y equal 1, you get -2 times 2, so you get -4. Okay, so that's the first derivative. Now we need to find the second derivative by using implicit. So the second derivative, it's product rule, so we're going to have first, which is y minus 3. Derivative of the second, I'm just going to say is dy dx, because it is. Plus second, which is y plus 1. Derivative of the first is also dy dx. And now a super annoying thing is going to happen. We need to find the second derivative at 1, meaning y is equal to 1. So we're evaluating this at 1, 1. So we're going to end up with, when you plug in, you get -2 times -4, because that's dy dx, plus 2 times -4. So you get 8 minus 8, you get 0. Super annoying. Should have thought about that ahead of time, but I didn't, because I just write the problems and then I do them when I'm making the videos. So the second degree Taylor polynomial is actually the same as the first degree Taylor polynomial here. So it's actually just this tangent line. 1 minus 4 quantity x minus 1. I don't know. We did all the work. I mean, that's what was required. So there you have it. A better problem probably would have had a different second derivative, but I needed to use not... I don't know. If you go back and look at the slope field, it does not appear as if a quadratic is going to nicely model anything going through this thing. So I don't know. They're either going to be just very messy problems or work out the way that mine worked out. Anyway, let's look at the next one. So this is calculator. We want to find the volume of the solid with base R, the region in the xy plane bounded by f of x, which is natural log of x plus 2, and g of x equals x squared minus 1, with cross sections perpendicular to the x-axis that are rectangles with height 5 times the base in the xy plane. Okay, so I'm gonna play a video of me doing this on the calculator. We need to know when f of x is equal to g of x. The calculator will show us, or will have shown us, that that occurs at -1 and 1.50102, which I'm going to call b. We need to figure out what we're doing for this cross-section thing. So there's a rectangle. The base is just going to be top takeaway bottom, which is f of x minus g of x. The height is going to be 5 times that, so it's going to be 5 times the quantity f of x minus g of x. And then what we need to do is we need to do the integral of the area of a cross-section. The area of a cross-section is base times height, so 5 times the quantity, 5 times the quantity f of x minus g of x squared. Right? It's 5 times the quantity f of x minus g of x times f of x minus g of x. I have this weird problem where sometimes I say 5 instead of f, or f instead of 5. I don't know if anybody else does that, but that's what kind of happened to me there. Okay, so the volume will be 5 times the integral from -1 to b of the quantity f minus g squared dx. Calculator is going to tell us that that's approximately 20.502. Add in a graph page. And then for f1, I'm going to make it the natural log of x plus 2. And then for f2, I'm going to hit tab, do x squared minus 1. All right, we're going to find the intersection of these curves. So that's going to be menu 8, 1, option 4. Menu 8, 1, 4, I just have it memorized. I don't actually even know what it does. I mean, I know it's finding intersections. I don't know what the exact name of that is. Probably intersection points. I'm going to press escape. And then what I want to do is I need to store these values. So I'm going to arrow. I mean, you don't really need to store -1, but I'm going to arrow over it. I'm going to press Control and then Menu. So that's Control and then Menu. It doesn't show on the emulator, so I'm just going to do it. Control Menu. Option 5 is Store, and I'm going to store that as A. I'm going to arrow over this. I'm going to press Control Menu again. Option 5 again. I'm going to store that as B. Now what we need to do is we need to actually find the value of this thing. So it's cross sections perpendicular to the x-axis, rectangles. The height is 5 times the base in the xy plane. So let's just see, F1 is on top, F2 is on the bottom. All right, I'm going to add in a calculator page. So that's doc 4 and then option 3. So what I want to do is I'll do an integral. So I'm going to do shift and then plus. And I want to go from A to B, or from -1 to the B value. There's no reason to store -1 to this. And then I'm going to press tab. And now I need to do 5 times. The base is going to be top, take away, bottom. And then the height, so it's 5, the base, what is it? The height is 5 times the base. Okay, so the base is top, take away, bottom, which is F1 minus F2. So I'm going to do parentheses, F1 of x minus, and then F2 of x. So that's the base. And then the height is 5 times that, so I'm going to end up with this. Just make sure you're squaring the correct thing, not just F2, but like the whole thing. I'm going to hit tab, x, and we want a decimal. Because B is very much a decimal, this is going to spit out a decimal no matter what we do, but Control Enter would always give you a decimal. So that's the answer that we get. Let's go back to the handwriting stuff. Okay, that's the entire problem set. I hope this was helpful, and good luck.